Righto guys, welcome back. Just let me adjust that, that's better. So in this video we're going to look at enhancing what we've been doing with graphing absolute value functions. We want to be able to work up to graphing something that's of the form y is the absolute value of some linear function ax plus b plus or minus some other constant that's on the outside. So let's start where we left off last time with looking at the graph of the absolute value of 2x minus 3. What I told you to do was to think about what the graph of 2x minus 3 might look or would look like. That normally would cut down here at -3. It'd have a gradient of 2, so its x-intercept would be up here at 3 on 2. So how do I get that? Well, very simply, the x-intercept would happen when this part is equal to 0. So for the x-intercept of y equals 2x minus 3, we let y equal 0. In other words, 2x minus 3 is 0. Simple algebra, x is 3 on 2. Okay. So our graph would normally pass through like that. But remember, the absolute value means that we're never negative. So our graph is only going to be positive. We're going to be up here. But when we hit our x-axis, we don't go into the negative. We bounce off and we go positive. Okay, so instead of cutting the y-axis down here at -3 where it would have cut, it's going to cut up here at +3. This half of our graph is y equals 2x minus 3. This half of our graph is the negative of that. Y is -2x plus 3. Okay, we saw that last time. We're just seeing it again. What I want to do now is to say, well, what would happen if I came along, say, and had a +1 there? So what changes then? So if I've got y equals the absolute value of 2x minus 3 plus 1. Well, we've already seen what a +1 does. It shifts our graph up. And if it was a -1, it'd shift it down. So exactly the same things that happen that we have. Instead of our graph, so the axis of our graph would still be at 3 on 2, because the +1 only shifts our graph up or down. Remember, it doesn't move it left or right, it's only moving it up or down. So our axis will still be at 3 on 2. Our graph will still be that Z shape. It's just everything is the same as over here, except we've moved up by 1. So instead of cutting at 3, we're now going to cut at 4. Instead of bouncing off here at 0, we're going to bounce off here at 1. Okay, so make that a bit clearer. That's a 1 there. That's a 4 there. Okay, so our graph is going to look like that. This half of our graph is going to be this line here plus 1. So y equals 2x minus 2. And this half of our graph is going to be this graph plus 1. Y equals -2x plus 4. Okay. Now, okay, well, that should be pretty straightforward. I know that it looks complicated. That looks very complicated, and the graph here looks a lot more complex than that nice normal vanilla y equals the absolute value of x graph that we saw. Let's extend it just a tiny bit further. Let's say that instead of a +1, we had, say, a -3 or a -4. What would that introduce? Well, that would bring this whole graph down beneath the x-axis. Right, so I'll just swap colours just for the purpose of demonstration. So if we had, instead of y equals the absolute value of 2x minus 3, if we had y equals the absolute value of 2x minus 3 say with a -4 added to it. It'd take this graph here and shift it down 4 places. So that's -4 there. That's where my graph would be bouncing. Okay. This half of the graph would be that function there +4. So it'd be y equals 2x minus 3 plus 4, y equals 2x plus 1. Sorry, forgive me. I just said +4, it's -4. Sorry guys, bad morning. Sorry, we're not adding 4, we're shifting down by 4. So we're going to be taking away 4. This graph here will be y equals 2x minus 3 minus 4. So it'll be y equals 2x minus 7. Same on this side. This graph would be minus 2x plus 3 minus 4. So that would be y equals, I'm just going to subtract 4 from this function over here. It was minus 2x plus 3. That's going to be minus 2x minus 1 because I'm subtracting 4. Okay. Now, there's a couple of more features. So in this example over here, the only sort of feature that we had was where does the thing now cut the y-axis? The only interaction it has with any of the axes is this intercept over here. But look, in this case, this red graph now has 2 x-intercepts and a y-intercept. Okay, so finding them is some pretty simple algebra, really. And we actually, I'd recommend starting with the graphs like we have and then doing the algebra to find out where the intercepts are. So to find the x-intercept there, I let y equals 0 over here. So to find this x-intercept, I let y equals 0, so 2x minus 7 is 0. In other words, x is 7 over 2, or 3.5. To find my x-intercept over here, I let y equals 0 over there, so I've got minus 2x minus 1 equals 0. So if I rearrange that, I end up with x equals -0.5. And then the y-intercept here is very simple, it's just the constant term there. So my y-intercept is -1. Okay, so look, that's, I mean, you'll be getting towards the very end of the exercise 4D by the time you get to that sort of thing. Don't look at it now and think, oh no, panic. Do the earlier work. Do the first few questions to have your graphing very simple, absolute value graphs. And I'm sure by the time you get there, you're going to have a lot better chance of having a successful attempt at it. Don't let any difficulties stand in your way though. If you have any problems, any questions at all, question in the comments below or in our Microsoft Teams page. If you want access to the Microsoft Teams page, check your email. An invitation was sent to you yesterday. Thanks guys, good luck.